Okay, in the last maths video and maths and computer science video, I started on matrices and matrices operations, and I started to look at inverse of a matrix inverse. First of all, I should say that really these are for as much for my revision as they are to help in other people's. So if I sound like I'm struggling when I go along, I usually am. So I'm gonna get right into the method. I'm gonna abstract almost everything, because I like to get down to the methods rather than to get bogged down with the arithmetic as we go along. So if we're going to find the inverse of a 2 by 2, let's start nice and easy. So we have 2 by 2 matrix A. Say it's 4, 8, 3, 10. We want to find the determinant of A, which we use this symbolism for. Usually we use this for absolute, but with two bars on either side, the bars on either side in this case mean it's the determinant. So I think I went over this in the last video, but just to go back over it, it's basically on a 2 by 2 matrix, to find a determinant we multiply the corners together. So 4 by 10 minus 8 times 3. And if this is not equal to 0, then it's a tick. So in this case, we can see quite easily that it's not going to be 0, because 8 times 3 is 24, 40 minus 24 is not 0, so that's a tick. This has an inverse. So the next thing we need to do is find the adjugate, and that's just a simple method really that we just need to remember. So to find the adjugate of A, what we do is we take our matrix that we were working on, so 4, 8, 3 and 10, and all we're going to do is invert, we're going to switch the 4 and the 10, so the top left and the bottom right. So we're going to switch A11, A22, and we're going to multiply A12 and A21 by minus 1. So you end up with 10, watch the camera there, minus 8, minus 3 and 4. And that's your adjugate. Then we just have a simple formula for finding the inverse, and I want you to remember that formula. The formula is 1 over the determinant of A times the adjugate of matrix A gives you the inverse. So in this case, we would just write it down. And again, I'm not going to go through all the maths, I'm just going to write this down so you see what you'd actually do. It'd be 1 over 4 times 10 minus 8 times 3 times 10 minus 8 minus 3, 4. So this works out to be 1 over 16, which would give us 10/16 minus 8/16 minus 3/16. I said I wasn't going to do maths, but I lied. 4/16, which simplifies to our inverse, which is 5/8 minus a half minus 3/16, 1/4. So there we found the inverse of a 2 by 2 matrix. It gets a little bit hairy now when you move on to 3 by 3, but we're going to go for it. The actual formula is going to be the same. We're going to use the 1 over the determinant times the adjugate of our matrix, which we are defining as A. So if we have matrix A, and I'm going to use almost all abstraction for this again. So A, B, C, D, E, F, G, H, I. There. So let's think about how we found a determinant of a 3 by 3 matrix. So the old method, or the first method that we did in the last video, for each of the elements across the top, we found a determinant, or use that as a coefficient of the determinant of a different section along the bottom. So it would be A times the determinant E, F, H, I, and then it's B times the determinant of D, F, G, I, and then it's C, and you can see where this is going. Getting a little bit confusing there, but never mind. Times the determinant of D, E, G, H. Now we're going to use this idea of sort of cycling along the top and splitting up the bottom in the method for that we're going to use to find the inverse. So this is called the matrix of minors, and it's going to be replacing the A is going to be the same the determinant of the same group that we related to A and for the last method. So it would be, assuming it's the determinant E, F, H, I. So not that matrix, but the determinant of that matrix. We'll D there. Then here, replacing the B is the determinant of the D, F, G, I, and so on and so forth. C is this group here. As we move to the second row, you basically do the same thing, but using the rows that you're not moving along. So for A21 is going to be the determinant of B, C, H, I. Here, 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 here. And then here is going to be the determinant of A, G, C, I. Just so you can see it in place there. And then the determinant of A, 3, 1, sorry, a free one is going to be the determinant of, so G is replaced by the determinant of B, C, E, F. And it moves along there, and that's how you create this matrix. Then you work out those determinants using the determinant for a 2x2 matrix, which we've done very recently. I won't go back over that again. So I'm going to cheat now and just do abstraction again, and we get something called our matrix of minors. So J is just the determinant of E, F, H, I. K is the determinant of D, F, G, I. L, forgot my alphabet there for a second, is the determinant of D, E, G, H. M is the determinant of B, C, H, I. And you guys can figure the rest of that out as I move along here. So we have our matrix of minors. So from this matrix of minors, we're going to work out something called the cofactor. So the cofactor is just multiplying this, if you like, by another matrix. Well, not multiplying it by, we're going to change the signs depending on this kind of pseudo matrix. It's not really a matrix, but we're going to change the signs. So we're going to apply these signs to the matrix of minors. So plus, minus, plus, minus, plus, minus, plus, minus, plus. So you can see that if they were, for instance, if k was 6, it would then become minus 6. If k was minus 6, it would become plus 6. So we've got something called the cofactor now. Which is going to come in handy later. I'll have to draw that out again towards the end of the video. Now I'm going to quickly run through an alternative method for finding the determinant of a 3x3 matrix. If you have A, B, C, D, E, F, G, H, I, we're going to add on A, B, D, E, the left hand side of this matrix. And then what we're going to do is, starting here, we're going to multiply these together down these diagonals. I haven't drawn these very well. So this is a much quicker way, in my opinion, than the other way that we showed. But the other way did demonstrate some useful things. So you have 6 sums there. So it's if you can visualize that, you multiply these together, plus these multiplied together, plus these multiplied together, take away this plus this plus this, and that gives you your determinant. Okay, so we've got our determinant and we haven't got our adjugate. Instead we've got 1 over a, but we haven't got our adjugate. So remember the formula for finding the inverse, 1 over a adjugate a. So the adjugate a is just the transpose of the cofactor. So the cofactor, which was, if I remember rightly, plus j minus k plus l minus m plus n minus o plus p minus q plus r. The adjugate is the transpose of that. So now we've got the adjugate. We've got the adjugate, so we've got the whole thing. We've got 1 over the determinant, we found a determinant twice, and we've got the adjugate here. And if your brain hasn't exploded yet, you're better than I am.